Everyone. Welcome to the March edition of the Data and Technology Outlook series. I'm Julia Lane, and I'm the Executive Director of the Center for Data and Computing at the University of Chicago. This is a series where we present critical conversations between industry leaders and researchers pushing the frontiers of data science forward, presenting and discussing new approaches that will define the next decade of technology and science in industry. This month, the conversation is focused on AI, agriculture, and food systems, and we'll focus on what it really is, why it matters, and what are the broader implications. We're interested in this topic because our center at the University of Chicago is focused on interdisciplinary research that has an outsized impact on the real world. And AI and agriculture and food systems are one of those critical topics that we're really excited to be discussing. Additionally, our center looks at other research areas, including AI-driven materials discovery, broadband access, machine learning for targeted cancer therapy, and other research topics. I hope you'll learn more about our center if you are interested. So I'm really delighted to welcome our distinguished speakers today to this fireside chat. I'll be introducing them momentarily. If you are joining on the Zoom webinar or on the YouTube live stream, we really welcome your input and your thoughts and your questions during the talk. So if you like, we'll probably spend the first half of the hour with a fireside chat. But if you have questions for our speakers, please feel free to submit them using the chat function on either the live stream or the Zoom webinar. All right, well, without further ado, I am so delighted to welcome our distinguished speakers. Today with us, we have Ranveer Chandra, who is the Chief Scientist at Microsoft Azure Global and a partner researcher at Microsoft Research. Ranveer has launched and provided leadership for several major research initiatives at Microsoft, including battery research, white space networking, and FarmBeats. FarmBeats is an AI, edge, and IoT for agriculture research project. Ranveer has also published more than 80 papers, filed over 100 patents, and is active in the networking and systems research community. Welcome, Ranveer.
Yeah, nice to be here, Julia.
Okay, so additionally, I am really delighted to welcome Supratik Guha, who is our moderator today for the fireside chat. Supratik is a professor at the Pritzker School of Molecular Engineering at the University of Chicago and is senior advisor to Argonne National Laboratories Physical Sciences Engineering Directorate, where he leads the lab's microelectronics and quantum information science strategic efforts. His research focuses on new materials and systems for information processing and sensing. All right, without further ado, I will turn it over to our distinguished speakers. Thank you.
Thank you, Julia. Ranveer, we just heard about your many distinguished accomplishments at Microsoft, where you're the chief scientist at Microsoft Azure. And as I understand, your responsibilities there have continued to grow. And recently, you've also taken up the role of managing director for all business engagements there. In particular, you've taken up responsibilities for managing Microsoft's networking research. So perhaps you could start off by giving us a bit of a deeper dive into your role as chief scientist. What are some of the key projects that excite you? Yeah. And tell us a little bit about it.
Yes, Supratik, it's great to be here. Good morning. And as part of one of the things I'm doing is I'm chief scientist of Azure Industry. What it is at Microsoft, we are thinking what is the future of all industries as it gets more data driven, like FarmBeats is for agriculture. What is a similar future for financial services? What is a future for retail, for gaming, for media entertainment? So those are the things that we are trying to envision and trying to see what is that data-driven future and how we should be thinking about it. In addition to that, I serve as the CTO for agriculture and food at Microsoft. So everything related to anything about food and what role should technology play, what role should Microsoft play is something that I'm looking at. And as you mentioned, I'm also leading the networking research group at Microsoft, thinking about what is the future of the internet, what's the future of data centers, 6G, and driving that initiative as well.
Well, your background is in networking and systems research, and you now run Microsoft's activities in agriculture and its impact on the environment and batteries. And what led you to this transition?
Yeah, that's a good question, Supratik. As you know, my background, my PhD is in computer science. I'm not an agriculture scientist, but I did spend a lot of time growing up in India. My first 18 years, I used to go to my grandparents' farm in Bihar, which is in northern India. Like as kids, as many people, if there are people from India who can relate to it, you spend a lot of time with your grandparents growing up. So I used to go spend time with them. It was in a village. And back then, I did not like anything to do with agriculture. These villages, they did not have any electricity. They did not have any bathrooms. It was in the middle of nowhere. And yet, like 3 to 4 months every year, I would be spending time with them in these villages. That said, it did expose me to a lot of poverty, a lot of primitive forms of agriculture, like bullock-driven tractors, hand-based seeding, and things like that. And that was one of the things which inspired me. It was in the back of my mind that that's something I want to do in the agriculture and food space. At Microsoft, as you said, I've been doing networking, doing that for a long time. And that's when one of the things that came to me was if the farms could get connected, if you could start getting data from the farms, you could help improve the lives of farmers. You could rethink what the future of agriculture should be. So it was a combination of both. On the one hand, it was my own personal experience. On the second, my research background actually helped. And that actually combined with the food problem that exists right now. That is, the world needs more food to feed the growing population of the world. It's not just about growing more food. We need to grow good food, nutritious food. We need to give people good food. And we need to do that without harming the planet. That is, the water levels are receding, the soil's not getting richer. How do we grow more, better food? So all these three things combined led to the start of the Farm Beats project.
This is fantastic. Yeah. And there's increasingly more interest from, sort of systems level people, engineers, computer scientists in this field. And it is very appropriate. As you mentioned, there are anticipated food shortages. The total amount of land that is used for agriculture has doubled in the past 100 years. And it's had consequences, right? There's, the pollution is a major issue. Nitrate fertilizer is overused by factors of about 2 to 5 or so. So the topic of today's discussion is, AI for food systems and agriculture. And perhaps you could give us your perspective on, what are the challenges that are important that we need to solve? And then what are the developments and tools that, artificial intelligence has brought that we can bring to the table over here? It's my feeling that AI and machine learning has impacted the business of agriculture less than it's impacted other major businesses like medical, for instance. So what do you think are the challenges? What are the tools that developments in technology that have come up that we can use?
Yeah, and that's a great point, Supratik. As you said, that there was actually a study by one of the big analyst firms which looked at 23 different verticals in terms of digital transformation, as in how much is the adoption of digital technologies. And this included retail, mining, all of those stuff. And agriculture was ranked last in terms of digital transformation paired with hunting. So it's bad. And there is a reason it is bad, as you said, right? Most of these farms don't have good connectivity. You're not getting data. There are problems around technology savviness. The farmers are not the most technology, as in IT savvy. They are technology savvy, but not really IT savvy. There are issues around literacy, around just data sharing. It's hard to get a lot of data from the farms. These farms they don't have power outlets. So there are a lot of these issues which actually lead to very interesting computer science challenges as well. But that's been one of the bottlenecks, that it's just hard to get data from the middle of the farm to drive a lot of these data-driven decisions. And once you do it, you could use expensive ways to get that data. You could use satellite compute, you could use satellite connectivity, you could use a lot of other ways. but then it increases the cost. So that leads to the second problem, that a lot of these technologies are not affordable. And in fact, there was a study by the USDA that said that that's what has led to the lack of adoption of digital agriculture techniques in agriculture. So then to the other question you asked is, how can AI help? And which is where I think what we need to do is, if we can start getting data from the middle of the farm, then you could start enabling a lot of efficiencies for the entire agriculture and food system. So when we think of a digital ag food system, we think of all the way from input companies, the seed providers, the chemical providers, to farmers who produce the crop, all the way to the distributors, the food processors, the retailers, in some cases, the consumers as well. If you can start getting data from throughout the supply chain, you could then start improving a lot of efficiencies in every component. If a farmer can get data, they can start improving their efficiencies. If a logistics company can start getting the data, they can then start improving their efficiencies. But the key thing on top of that, which if you could start sharing the data across the supply chain, that could then drive additional efficiencies as well. So let me make it more concrete, just in the context of farms, as in how do you make a farmer more productive with AI? So when I started the Farm Beats project, and actually I started it in end of 2014, before that, I spent quite a bit of time volunteering for farms, meeting farmers. What I realized is that I met a lot of farmers in different parts of the world. What I realized is that these farmers know a lot about their farm. They've been farming there for decades, if not generations. Like there was a farmer who could pick up the soil, feel it, and say what's going on. There was another farmer in upstate New York. He would pick up the soil, taste it, and say, you know what, this might be going on. So these farmers know a lot. Yet, a lot of decisions they took on the farm was based on guesswork and intuition. Like even though they know a lot about the farm, yet when to water, when to apply pesticide, how much fertilizer to apply, when to plant, when to harvest, all of these decisions was based on guesswork. So that's when the key insight was that digital agriculture with Farm Beats, what we thought was bringing technology to augment a farmer's knowledge with data and AI. That is, if a farmer who's very knowledgeable could start using AI to make predictions, could start using they could start making data-driven decisions. Like if you could start predicting at that farm, what is the weather going to be over the next day, over the next few days, even over the next few months, which is like a very hard problem. But if you could, the farmer with their knowledge about what's happening in their farm can take very good, very much better decisions, which can help them be more productive. Another use case of AI I'll talk about is for precision agriculture. When we talk of precision agriculture, this is about site-specific application of inputs. That is, in a farm, where do I apply water? Where do I apply pesticide? Where do I apply nutrients, herbicide, and so on? Or do site-specific seed placement. But if you have to really realize the potential of precision agriculture, you need accurate maps of farm. Like what is the soil moisture 6 inches below the soil throughout the farm? It's hard to put a sensor. If you have to really build an accurate map, as you know, you would have to put lots and lots of sensors, but putting lots of sensors is difficult. So then what AI can do is it can help plan intelligent placement of sensors. It could build these maps by very few sensors. It could merge different data streams to build these very accurate maps, which could drive precision agriculture decisions. These are just few use cases. Of course, if you extend it, a lot of work that you all are also doing in AI farms is around robotics. You could then start bringing in automation in the farm. So the potential of data and AI in agriculture is huge. I think it can really transform the way we eat, and in the process, the farmers' lives. It can help improve the planet. Really excited, pumped up about what AI can do for agriculture.
That's very well described, Ranveer. You mentioned about cost. That, in my view, is sort of the biggest thing limiting the use of these technologies, right? The first farming or agricultural business where this type of technology will probably make an impact is likely the wine industry or the almond industry, where the wine industry is roughly ballpark about $10,000 to $15,000 an acre. On the other hand, if you look at what's going on, the main crops in the Midwest, corn, soy, For corn, a farmer on average, as I understand from my colleagues in that area, the total expense is about $700 an acre, right? If I were to buy a moisture sensor, you talked about moisture sensors, a good, reliable moisture sensor from Meter that'll go inside the ground is, $200. If I buy maybe a huge number of them, maybe the price goes down to $150, $100, right? And you talked about data resolution. For soil, you need this data on the scale of maybe 10 meters, 20 meters, ideally, right? And so you can estimate the cost. I had long discussions once with a colleague of mine, who's sort of a visionary guy who ran research for Gallo wineries. And his picture was that eventually he wanted a sensor at every plant. And then this now morphs into the question of, well, can the plant become a sensor? But then once those things happen, you talked a little bit about machine learning and AI and how it could bring all that data together and harness it, which leads me to the next question. AI has been very successful in data that's come out of a computer, right? Pictures, sales data, stuff like that. We're now talking about physical data, right? And data for which it's difficult to get ground truth samples. They're very expensive. So can you talk a little bit about the foundational challenges in artificial intelligence, in computer science, from a fundamental development of the field perspective that needs to happen so that it can be harnessed for agriculture and other applications in the sciences?
Right. And Supratik, you touched upon one of the core issues where we are looking to collaborate with you on how do you really bring down the cost of these sensors. And like right now, these sensors, because one of the, as you mentioned, if you have to drive good AI, bring good AI models, you need good data. And to some extent, your AI is as good as your data. And if you want good data, you want inexpensive sensors. You want large amounts of good fidelity data coming to the cloud so that you can train your models, so that you can then drive some of these predictive decisions. And so, and as you said, right now, probably the first adoption is in these high-end cash crops, like with almonds, with in wineries and so on. The next would be these broadacre crops. My guess is the third is going to be horticulture. And eventually it'll get to the emerging markets, because in the world, there are about 500 million, close to 500 million smallholder farmers. And how do you get technology to them? And that's something which is going to be, it's one of the frontiers we need to capture. So going back to your question around what are the key challenges around technology and AI, I think one of the interesting things about when we think of digital agriculture is it touches upon all areas of computer science. That is, if you have to solve the networking problem, that's number one problem, because you need to get data, you need to go to the SIGCOMM community. So think about how can you bring connectivity to remote parts of the world in an inexpensive way. So connectivity is one of the problems we could just have a deeper dive on, given some of the things that we've been doing. The second is, of course, once you get the data, it's about sensors as well, which you touched upon. How do you make the endpoints inexpensive so that you can start getting more high fidelity data from the remote parts of the farm? Once technology that we built there was on Wi-Fi based sensing. This is a paper that we published a couple of years back, which was on, can you use the Wi-Fi on your phone to start sensing soil? This was the key idea behind that, was that if farmers right now, as you mentioned, they don't want to buy a sensor and put it in the farm, just one sensor, because especially if you think of smallholder farmers, what is the return of investment if I put one sensor in the farm? But many of them have a smartphone, even if it is a $100 smartphone. If they have a smartphone, it has a Wi-Fi chipset in it. The key idea we developed was if you use Wi-Fi, the time of flight of Wi-Fi, to measure soil moisture or soil electrical conductivity, that could be one way in which you could democratize sensing. That's one way, but I think that coupled with inexpensive inventions in some discoveries in material science, I think that's going to be key. Combination of these techniques. So going back, I think it's about getting good data through good connectivity, through good sensors is one of the core problems. But once you get this data, that leads to another challenge of how do you do AI on top of it? That is, one problem is that Even with satellites, so the satellite data, remote sensing there's been a lot of work in remote sensing. But if you start thinking of its application for, say smallholder farmers, each pixel that you're getting of satellite data might correspond to multiple crops that a smallholder farmer might have planted there. So how do you extract information from it? That's one of the challenges. The other thing I've realized is that, as what you're doing in AI farms as well, is when we think of what can AI enable, AI can enable us to get a view of the farm, both above the soil, that is the plants, and below the soil as well, roots as well as the soil, and not just what it is now, what it was in the past, and what it will be in the future. If you could build that view of the farm, that could then drive a disruption in digital agriculture. But building that view itself, there's no single source of information that can tell me what my farm, what my soil looks like inch by inch in the farm, above the ground and below the ground. And so to enable that, we need inventions in AI. We need multimodal AI. We need all the work on that's happening on automatically labeling all the AI data. We need inventions on new AI schemes on things like federated learning. One of the issues that farmers have is they don't want to share the data. A lot of times they are very possessive. They have data privacy concerns, which means that if this data is disaggregated, then you still train your models in a way where the data is trained, the models are trained in a distributed way, but it's all then adds up so that you can then build really good models. So there's a lot of innovation that's needed even in core fundamental AI, but a lot of it is also needed on how do you get this data to build your AI models.
Yeah, you touched upon the question of data management, right? And this is something that, I'm part of this NSF USDA center that my colleague Vikram Adve from UC Computer Science runs. And what I understand is from talking to my colleagues in agriculture and soil sciences is that there's all this disparate data, right? You talked about farmers having data and all that. They'll give you data if it's worth their while. So there has to be some kind of a deal there. Then how do you sort of aggregate all of that data and make it available in some fashion to the computer scientist who then is able to look at it? And that is a huge challenge in this area. But I want to go back a bit to the question of wireless connectivity and broadband access. I know that's a favorite topic of yours, and you've talked eloquently about white spaces in the past and worked in that field. And I find that when I've talked to people who run farming industries or people in the animal farming business, I asked a lady who's the vice president of the National Pork Board, what is your biggest challenge? And she said the biggest challenge is broadband connectivity. And to essentially paraphrase what she said, where she said, look, companies come to us with all these apps of taking pictures of pigs and counting them and stuff. But then how do I hook that app onto the internet? I can't do that. So can you comment a bit more on this whole problem of broadband connectivity? That really seems to be a huge issue for these guys.
Yeah, and you touched upon, Supratik, that right now during COVID, we see this digital divide that we take broadband for granted, but we need to realize that a lot of people in the US and around the world don't have internet access. That is, more than 40% of the world are still not connected to the internet. And a lot of times, one part of it is around lack of infrastructure, but the other part of it is lack of affordable access. That is more than, like I said, 60% of the world is connected, 40% is not. You're talking of close to 3 billion people who don't have internet access. And among them, more than 90% have some sort of connectivity available if they could afford it. So it's also about affordable access. The other thing is that there is a gender gap here as well. There is more women who are not connected than men, which leads to another problem that we all need to address. So this is just about access, and a lot of these access problems occur in the rural parts of the world. In addition to that, when we think of precision agriculture or all these digital agriculture scenarios, it's not just about connectivity in the farmer's house. It's about connectivity in the farm from where we want to get data. And that is another challenge. In fact, there was a recent study which talked about only 25% of farmland in the US has internet access. So if you think of it, 75% does not. And how do you get data from those farms? So we need to address this problem of rural broadband. The question is, how do we get there? How do we bring connectivity in the rural broadband? Because if we have to think of a future of agriculture that's data-driven, we need to provide connectivity. And not just connectivity, we need to provide broadband connectivity in these regions. One of the things, and that's where the other day I was talking to Nick Feemster, and he's done some amazing work in measurements. And I was telling him this is one area where we really need his help, is to accurately measure how much of the farmland is covered. What is the big gap in connectivity? So one of the other things we need to do here is when we think of digital agriculture, redefine broadband. What is broadband for farmland? When we think of broadband in the house, when we buy a broadband internet access, broadband by the FCC is defined as 25 megabits per second down, 3 megabits a second up. When you think of farms, broadband there is different because at home we are usually consuming content. We are watching things from Netflix or other places. In the farm, it's mostly about uplink. It's not much about downlink. Most of the times your cameras, your drones, your tractors, they're uploading data. So then you need much more uplink bandwidth than downlink. So one problem there is measurement of data, defining. So there is a huge aspect of policy where I know Monisha is driving some really awesome work at the FCC around rural broadband and rural broadband's application for agriculture. The other part of it is what innovations exist. And there are lots of innovations happening in making this possible. One of the things we are looking at, you mentioned, Supratik, was TV white spaces. What this refers to is empty TV channels. That is, can you use an available TV channels to send and receive data? That is, when you browse through TV, this is TV with over-the-air TV with antennas. On certain channels, you get a transmission, others you don't. So can you use unused TV channels to send and receive data? And the interesting reason why this is so cool, so appealing for agriculture is that TV towers are in cities. You have TV towers in Seattle, in Chicago. In the middle of a farm, most of the channels are just white noise. So this is tens of megahertz, if not hundreds of megahertz, which means that you can then start using it to send and receive large amounts of data. And the benefit of the TV spectrum is that compared to Wi-Fi or upper parts of the spectrum, the signals propagate really well. It goes through trees, crops, canopies really well. And the FCC recently approved regulations. They modified the regulations to allow higher power transmissions, longer range transmissions in these parts of the spectrum, which is really appealing. That is one. We are also looking at other ways. We just announced at Microsoft this thing called Azure for Space, where we partnered with Starlink, SES, and other companies, where you could think of space-based connectivity coupled with some terrestrial mechanisms. Like I talked about TV white space, it could be a private 4G or in the future, a private 5G kind of a network, where coupled with all of this, you need to bring together all of these technologies to make broadband more affordable. But to answer your question, like to summarize this, is that if we have to enable digital agriculture, we need good broadband access in rural areas, not just in the farmer's house, but also in the middle of the farm.
Great. That was a very passionate case made for broadband in rural areas, Ranveer. Thank you. Let me turn the topic to another really important area, that is regulation, right? That controls all of this, that in the end, the scientist can maybe classify things, understand things, along with machine learning and make recommendations. But in the end, it has to go through this whole regulatory business, which also in turn connects how we impact the environment, right? So for instance, fertilizers, the Fritz Haber process for nitrates, for fertilizer, for ammonia, that, really improved, reduced world hunger significantly. At the same time, I think it's been one of the biggest disasters for environment. And fertilizers are heavily subsidized across the world, right? Today, a farmer would come and put fertilizer on his land here in the Midwest. If the rains fall and the farmer thinks that he would like to top it up again, he'll put fertilizer again because we can't measure nitrate in soil accurately or cheaply. And it's cheap for him. It's about $10 to $15 an acre is what I understand from my colleagues. So we can make all kinds of predictions, but if that's the issue, then that nitrate then leaches into the soil, goes into the water, goes into the oceans, and does all kinds of things that are damaging to the environment. So how do you think we can use computer science techniques, artificial intelligence, and how do you see regulation fit in over here? Is there a role that we can connect here?
That's a great question, Supratik, and that's why when I was talking to other people at Chicago, I got so excited about this thing that when you think of impact, you take a complete look, including what should be done on the policy space as well. And especially for digital agriculture, we need to do a lot. And you touched upon some of those with respect to nitrogen application. There's some around food, there's around gene editing. There's a lot of policy work that's needed around just technology in agriculture. I'll touch upon a few, but this is no way comprehensive, right? I think there is a need to write a policy paper on what policy hooks are needed and how research can drive some of these policy decisions. I touched upon one of them around building such a rural broadband map, like building a map of broadband in farms. We need a good measurement study. We need a way to quantify that. In addition to that, I think there is policy. Some of the things were around like the TV white spaces work, where we had done some work, of course, working with academia as well. And the FCC listened to us, listened to all parties, and made regulatory changes which would enable broadband adoption in rural areas. So broadband is just part of the thing. I think another part is around data. I think there needs to be, in order to share data, there has to be some regulations around it. Even the use of AI on this data we should be careful about what AI mechanisms are allowed and how AI is used. It should be used in a way that, the same facial recognition system that you use to unlock your phone could be used to track people where they shouldn't be tracked. So getting some regulations around that to make sure that farmers are more comfortable sharing the data, and this data can be shared across the value chain. Because one of the things we touched upon earlier was to drive good AI, we need good data. And the data doesn't exist with one entity. You also touched upon that many entities have this data. How do you bring this data together? Part of it is a technology problem, things like using homomorphic encryption or encrypted AI. But the other part of it is regulatory. How do you enable people to share data so that there's some data audits, there's some regulations around that, around how AI is used, how this data can be captured and shared. And another part around digital agriculture, which I think should be mentioned here, is around having the right policies in place to drive the adoption of digital agriculture. Like you touched upon how nitrogen is subsidized. Why isn't digital agriculture subsidized as well? Why aren't there subsidies for growers to start using any of the data-driven agriculture techniques, use the apps, use the sensors, subsidize them so that the growers can start adopting it? It's important here in the US. I think it's even more important in the emerging markets where we need regulation around that. Another point I'll touch upon is around sustainability. That is, the farmers, one of the ways in which all of this could happen, that you could allow data sharing, you could incentivize farmers, is through this angle of sustainability, where with climate change, where many people would know, one of the problems with carbon is that, carbon above the soil is bad, carbon below the soil is good, right? You want to put more carbon back into soil. And one way you could do that is using the right agricultural practices, by using things like no-till, using cover cropping, using the right nutrient management so that you're not putting more fertilizer than necessary and things like that. And very recently with the new administration, there's this talk going about the carbon bank, where farmers can get money for using the right agricultural practices. So this is the kind of regulation but in order to make this carbon bank possible, you need digital agriculture. You need to know what's happening in the farm. You need to be able to verify, because it's a financial transaction. You need to verify whatever the growers claiming they did is actually what they did. So I'm hoping that these kind of umbrella policies, that like sustainability, it's an important one for all of us for climate change, and farmers could benefit in the process as well. There are many challenges to be addressed around that as well. There's lots of discussion going around the permanence of soil carbon done using agriculture. But at the very least, I think if the growers use the right agricultural practices, these days being termed as regenerative agriculture, then it could help the farmers, incentivize the farmers to do the right thing for the climate, but also for their soils. The soils will get richer. The soils organic content will get better. The nitrogen use efficiency will get better. And all of these, although these are agricultural problems, it can be enabled only through digital agriculture. And the innovations in technology are key to make that happen.
Yeah, that's a really interesting point about using farming techniques and incentivizing, digital ag-driven farming techniques to improve carbon sequestration or its retention within the soil. And of course, carbon in the soil is about roughly 20%, just like oxygen is about 20% in the air. We have time for one last question, or maybe two if they're quick. But I wanted to ask you. So Bill Gates is the largest farmland owner in the United States today, and Microsoft has made I understand several commitments to sustainability. Can you talk a little bit about that in terms of Microsoft's activity specifically in the area of sustainability?
Yeah, I'll talk about Microsoft's activity. Bill Gates, this is part.
Yes, of course, that's what I meant. Yeah,
Bill is very passionate about agriculture. He did blog about farm beats. I took him to the farm here, and he blogged about it. He's very passionate about agriculture and the role of agriculture with climate change in two ways. One, that he believes around that farmers are going to be the most affected because of climate change. And we need to use digital tools so that farmers are more prepared when there is any weather changes because of climate change. But the other part is around, can the growers use the right techniques to make the soils richer, to put more carbon into soil? So Microsoft, as you mentioned, we made big commitments around sustainability last year. One of the key ones was around climate change. This was last January, where we made a commitment to be carbon negative by 2030. What that means is that we are going to be putting back more carbon in soil than the amount of emissions that we generate. The way we get there is we are going to be reducing our own emissions through our data centers, through our products, but that's not going to be enough. We are also going to be purchasing the right credits from different sources. And we made the first purchase last year. We had a unique RFP out where we were asking people to and we got more responses from different organizations that were selling carbon offsets, and we did make purchases, including some in soil carbon from agriculture companies like Land O'Lakes. So we bought credits from them as well. So these reports are online, but we are one of the commitments was that we'll get to carbon negative by 2030. The other commitment was that by 2050, we are going to remove all emissions that we've ever generated from the time Microsoft was founded, which is, I think, a huge commitment from Microsoft's standpoint. And on top of that, our CFO, we put in $1 billion for a climate innovation fund, through which we are funding breakthrough ideas around carbon capture. We realize that existing techniques are not good enough. We need to invest more. So this is one of the areas in which we call it a moonshot from our side. That is, how do you help address the world's climate problem? In addition to climate, we've also made commitments around water, waste, and biodiversity, the ecosystem as well. And as part of that, we are building tools inside Microsoft, both to meet our own commitments. How do we make our data centers more green using sustainable materials, green materials, but also about how do we help our customers, our partners, meet their sustainability commitments, the agriculture companies, the supply chain companies, and so on. So yeah, it's a very big thing within Microsoft, and I think across in the industry where more people are becoming more conscious about their environmental footprint and what they need to do to help make the world a better place.
Well, thank you very much, Ranveer. This was a really engaging conversation, and you're obviously extremely passionate about this field. It shows. So with this, I think we have time for a few questions in a Q&A session. So I'm going to hand this over to Julia. Julia, all yours.
Great. Thank you both so much. What a fascinating and just, exciting conversation. You can clearly tell that you're both very passionate about this topic, and I'm just really enthusiastic that we were able to host you both. So we've got a ton of questions already from the audience. if you are listening right now, feel free to keep submitting them, and we'll try to get through as many as possible. But I want to start with a question from YouTube from Andrea. And she has a question I think either one of you can address. The question is, do you have thoughts on using AI to guide how much, what, and where to plant in the first place? For example, climate pattern impact on particular plots, past land use, and to guide food distribution post-harvest.
I could start, and Supratik, you should add.
Go ahead.
And really, this is, I think, one of the first problems that AI should address about what the farm looks like now, what it would look like, that piece of land, what it would look like, what's happened to it in the past. And based on that, being able to estimate which crop would grow better, what to plant. And of course, it could be multi-cropping, it could be like using crop rotations. It's not just a one-time decision, but what you should be doing, both in terms of increasing productivity, as well as what's good for your soil, and taking a longer-term view as opposed to taking a shorter-term view. And AI can definitely help. The data sources here would include all the data from satellite data to drone data, past management practices, past whatever's been planted in the farm, what's happened in the farm. All of that information would play a role. Also, other data sources, like, for example, the price of crops, historical price, what's the predicted price, what's the predicted weather in that place. All of that would come in to start making these predictions. There have been some initial tools that have been built. There are a few companies doing that, but nowhere at the scale of something which is optimal. And I think there is a role that research can play. And if there are potential entrepreneurs listening, this is something which can be enabled using data. We need all of that to start making these predictions.
Well, that's very good. I don't have much to add to this. This is a very well answered. Julia, perhaps the next question.
Great. So I'm going to ask one from Zoom. This is from Fabian. They say, you mentioned some good points about why farmers in emerging markets haven't switched to more sustainable practices that help the soil. So the question is, what needs to be done so that farmers don't take all the risk when switching to more sustainable practices? Because for them, the risk of losing their crops in 1 year by experimenting with some of these new sustainable practices could be economically devastating. So I think it's kind of, what's the risk mitigation strategy?
Yeah, so some of the tools we are building, Julia, at Microsoft, one is around a what-if analysis tool, being able to tell growers, being able to give them the tools to do, if I did this, what's going to happen? What's the impact if I adopt it? And it's not just about outdoor farming. It's the same with dairy farming, livestock, with other farming, other types of farming as well. We're being able to give them the power of, hey, if I did this, what's going to happen? What's the pros and cons? Providing more visibility. But the other part of it, which Supratik asked as well, was around the policy. That is, we need the right policies to enable growers to take the right decisions in the longer term. Where agriculture receives a lot of subsidies, some of these subsidies could be slightly in the longer term, allowing them to do something in the shorter term, which might not be as profitable, to help them take decisions which in the longer term will be more profitable and better for the planet. So I think there is a policy side to it as well. In addition to the digital tools, this what-if analysis tool, I think, is going to be key. We are building some of the components of it. At Microsoft, what we are building are just tech tools as part of the Azure FarmBeat stack, but then the way it will get to the market is through partners. Like, for example, Land O'Lakes recently announced a True Carbon initiative, which is going to be around that, and others are doing something similar. But I think that technology needs to be developed as well.
That's great. That's super helpful. I'd be curious too, since you both are involved in these kind of bigger research initiatives as well, and oftentimes those research initiatives include stakeholders. And so I'm curious if you've thought about how do you engage with stakeholders there as well.
Yeah, so Supratik can talk more about this, but AI Farms, for example, is this NSF USDA initiative that's happening, and I think last week where there was this leadership meeting, the board meeting where there's several company representatives and several stakeholders. There's stakeholders from the government, from academia, from industry, everyone coming together. And we need more of those to really drive all the changes that we want, all the innovations that we want to enable agriculture. Want to add more to that?
Yeah, I think in particular, agriculture is a very interesting area, right? So for instance, here, what we're trying to do is bring together, say, computer scientists and the So in the center, the NSF USDA center that I'm part of, we're trying to bring in, say, companies that represent conventional, IT-related business, IBM, Microsoft, et cetera, and along with agricultural companies, right? Companies from that business. And these two businesses don't talk to one another as much as, say, other sectors talk to one another, right? So that has been a very interesting engagement. Now, on top of that, in the end, your stakeholders are also the customers of this technology, and Vikram talked about adaptability by farmers. So for instance, on our board is a farmer, right? And same from the animal side of things, animal farms as well. So it's something that needs to be developed, needs to evolve. It is extremely multidisciplinary, and the challenge is going to be first understanding each other's language and then understanding how everybody can benefit from this, right? This is the challenge. I think thrown on top of this is the consequence of all of this technology to the large farm, small farm problem, right? Farms have been integrating and becoming more consolidated. I heard recently, for instance, in Wisconsin, many decades back, there were several thousand dairies. Now there's, only a few hundred independent dairies. And the same thing is happening in agriculture, and the same thing is happening across the world as well, right? And then the question is, do we upset that balance using AI and machine learning and information technology, or do we reset that balance, right? The advent of the internet, et cetera, for instance, has actually made it better for small-time journalists, et cetera, to thrive, right? Or the startup culture to thrive. How is this going to be for the farming business? I think that's a really interesting question. It's a somewhat, I've diverged a bit, but one of the questions that came up also brought me into this. And I think it will be really interesting to see how AI affects this small farm, big farm balance.
Yeah, no, that's a very interesting point, Supratik, about AI, because, there's one thing I hope, and one thing I know, I hope that a lot of farming just doesn't go the completely industrialized way, that farming is done the right way, and that has that human touch of farmers doing the right thing. And yeah, I think AI, and it should be developed in a way that no one is left out. That is, in the past, there has been this thing about technology being accessible only to a few. And we've seen this divide happen with broadband. We've seen this divide happen with just every technology. How do we make sure that all these innovations in agriculture are more democratized? It reaches every farmer, the farmer here, as well as a farmer in sub-Saharan Africa.
Thank you. Okay, so I have a good question here. This is a question about, do you have any advice for undergrads who are just getting involved in AI to get more involved in this issue?
I'll take that, Vikram.
Yeah, I'll start. And Supratik, you're an academic. You should say more to these students. I'm very passionate about talking to students as well. In fact, I love visiting schools because I get to meet students. So it's unfortunate that I'm not getting that opportunity here. To undergrads, I think it's great that you're even thinking about this. This is something top of your mind when you're thinking, hey, what are the skill sets I need to get in order to make a difference? This is a time when during your undergrad is when you learn a lot. And this also, when you start thinking about applications, when you think of AI, you start thinking of the improvements you could bring in the food system. I think there are many opportunities in agriculture. So the advice to you here would be, one, take more interdisciplinary classes, go learn about food, learn about agriculture, it involves learning about biotech, learning about other areas too, while maintaining your primary focus on computer science, learning the core AI skills that you're learning as part of your current curriculum, but get that interdisciplinary view. Talk to other people. That's one thing I didn't do much when I was, especially in grad school. I should have talked more to people in the agriculture school now that I'm working in this space. In hindsight, I think that would have helped a lot. But that's one thing I would advise. The second thing is if you're at University of Chicago, well, you're at one of the best places in multiple disciplines, and including in engineering, in science, in business. So that you could start thinking in terms of your entrepreneurial skills as well. We need smart people to make a difference here. There are some things which scientists would do. The other part is where we need new business models, new entrepreneurial, new business ideas, which is again something else I would encourage you to take part in hackathons, take part in all of these events to start building your skills, building the right network, and talking to people across in different schools, both or computer science or engineering, and all the other disciplines as well. But Supratik, you might want to add to this.
No, I think I want to echo your point about multidisciplinarity, and especially in something like this, multidisciplinarity is key. There's increased funding in this area, and just write to people working in these projects. They always need hands-on undergraduates building things, and don't be afraid to get your hands dirty. I think as this present younger generation goes into the workforce, they're going to have to increasingly keep learning new skills, right? You will be responsible for your brand, right? That's the way things are going in the future. And you have to constantly keep refreshing yourself. So that's something that I would really advise in staying as multidisciplinary as possible. When we built the first underground sensor network that we built, and right now we're in the second generation, it's a farm in Fermi Labs that Argonne runs, and now we're doing the third generation sensor network. But the very first generation was built by undergrads on the Hyde Park campus here. And Julia was actually very helpful to us at that time. And it was built by undergrads because, they knew all the hardware and software programming, and it came to them more naturally than it came to the professors. So there's always places where you will do things better than others and use that as a hook to get into this field.
Yeah, and like one of the students, and this is another thing at the students at University of Chicago, you get these opportunities. Like one of Supratik and Monisha's student, Ziki, she's now at Microsoft, and she talks about all the things she did in building this network and building this underground sensor network. You get these cool opportunities, participate in them. That will, you'll gain some invaluable skills. Ziki's doing something else now, although still she's very passionate about agriculture, she's passionate about quantum, but that's just one example. I'm sure there are other very bright students, and you could follow a similar career at University of Chicago.
Ziki graduated from the CS department at U Chicago just last year, I believe.
That's great. Yeah, I'd also just mention to that question too, our center, we have several research opportunities for undergraduates, and including summer research opportunities. So if we can recruit perhaps Supratik as a mentor to that program, you can work with him on these projects. Okay, so I'm going to ask just one last question, I think. We probably have time. And this is from YouTube, and this is from Ricardo. So we kind of going back to some of the more sort of data science questions here. His question is, considering some of the drivers for agriculture, including weather, soil, plants, their interactions, agricultural practices often make a huge difference on yield and production. And I think his question is, how are you using AI to model such drivers? So how do you then, this gets back to this fundamental question, right, of taking this data from all these different sources and then being able to then model it. So can you speak a little bit more about that?
I could take the first shot here. So there have been some, so this is a great question, by the way. And as he said, agriculture is very, very sophisticated, the entire process from the time you plant a seed to how it grows, how much yield do you get. And there have been process-based models that people have developed. These are simulations which will run at scale, which can try to model every seed, take in parameters, things like the AppSim model that came out of CSIRO in Australia, to others who built on it. And these are process-based models that people have used. These are simulations. The thing is that these process-based models don't really take real-time data into account, or data that you're getting from the field, to customize it, to make it more accurate. And this is and that's the thing where the farm management aspect comes in. Yeah, it does take a lot of inputs, like you could give in soil parameters, crop, climate, and so on. But what about other things, like what a farmer does? When do they do application of certain materials? This is where AI can help. AI in combination with simulation. And this is something which is at the cutting edge of what's happening in simulations plus AI. But AI can make your simulations better. And that's one thing where there's some recent progress that's happening, which I think is very promising for agriculture. There's also some work happening, and this is there's something around the AI farms as well around this, is around being able to realistically model a farm, what's going on in a farm. You can imagine a 3D simulation model of a farm, which you can then incorporate these process-based models, and you can see in how a plant will grow, how its shade might impact the amount of sunlight some of the other plants are getting, which would then make your models much better. So these are different ways in which AI can help, but it's more about it'll be building on a lot of work that has been done in this space, not real good, high quality work on building very good simulation models, these really good physics-based models. But on top of that, bringing in AI can make these models much more accurate, much faster, much more contextual for the particular farm which you're trying to model.
Yeah, I would add that is correct. My understanding is that the models are not accurate enough today. They are still in an earlier stage, and the models are not accurate enough today because there isn't enough data to completely cover an understanding of the physical processes and the variability involved. Today, for instance, there's only about one soil sample taken every couple of acres. You need 2 to 3 orders of magnitude more samples taken in order to be able to really model this thing. But this is where the research is aimed at, right? You've just pointed out sort of the heart of one of the key issues for the center that I'm part of, and a lot of other activities, including work at Microsoft, and many startups have mushroomed in this area as well, trying to predict yield and efficiency.
Yeah.
Great. All right. Well, we're out of time, so I want to thank you both again for such a delightful conversation. This is, really exciting and informative, and I hope everyone enjoyed it. I know I did, and learned something. If for the folks who are interested in these types of topics, I hope you will join us for our next speaker series in the Outlook. So this is going to be with Martine Casado and Nick Feimster from the University of Chicago, and they'll be discussing principles for AI in the real world, which is going to be thinking about the emerging technology stack for AI and businesses. So I think if you're interested in these types of topics that cross over research and industry, I hope you'll join us for the next one. Additionally, I just want to very briefly mention that on Monday, we'll be wrapping up our Distinguished Speakers Series, which is focused on socially responsible data science with Kate Crawford, who is a distinguished research professor at NYU and senior principal researcher at Microsoft Research. We clearly love Microsoft here, I guess, but please join us for that. And then finally, if you're interested and you enjoyed the conversation today, I hope you'll continue to engage with our center through social media and many of our other activities. You can learn more on our website. And with that, thank you, Ranveer. Thank you, Supratik, so much. We, greatly appreciate the time you spent today.
Thank you.
Thanks. Thank you.
All right. Thanks, everyone. Have a good one. Bye.
Bye.